In this video, we're going to do some sample problems off of the derivative sheet, focusing in this video on these three sample problems, 2b, f, and n. And what we're going to focus on here is structure, as well as standard of work that's required. So our first problem here, 2b, of course that doesn't work, 2b, y is equal to 3x to the 1/2 minus x to the 3/2 plus 2x to the negative 1/2. All right. Now our first step always is going to be to rewrite our problem in a better way. This problem is fine. There's no rewriting necessary. If this was written as a radical, we would want to rewrite this as an x to the 1/2. Having the explicit number for the power makes our lives a lot easier when doing the power rule. So now, here we go. If I'm going to take the derivative of this, I'm going to apply the derivative operator, ddx, to the entire expression. Remember, an operator has to be done to both sides of the operation because we're going to transform the right side. That means we need to transform the left side to see what it is that we're getting. So we get this dy dx, or f prime of x, or f of, whatever it is that you want to call it. And that says that the function that we're generating here is a function that describes the slope of the original function. That's the transformation here of meaning. This says the function is this. This says a function that describes the slope of y is this. What we'll be doing here. So our first step here is to do the sum rule. We're just going to write out our sum rule. And this is something that people say, oh, it's annoying to do the sum rule and show it. Sorry, in the calculus unit in this course, you will show that step every single time you will show a sum rule. So then we can just go to right to the answer here. Now, depending on your level of comfortability with calculus, you might want to do the same thing. Well, rather do this first thing. Show 3, just that coefficient remaining the same, and then parentheses 1/2 x to the negative 1/2, right? And then minus x, or 3/2 x to the 1/2, and then plus 2 times negative 1/2 x to the negative 3/2. Remember, always bringing down the power, and then raising the x to the 1 less power. Now, that's fine, because in terms of final product for this, because you have taken all of the derivatives, you are good. If your answer just went right to this, combining the coefficients with the new coefficients, that's fine too. So either of these would have been a fine next step from this. I would recommend, if you're just getting comfortable with calculus, that you are just showing that operation really specifically and then dealing with the coefficients separately later. So now next, we have 2f, which is y is equal to 1 minus 5x quantity to the 6. So I look at this and I say, okay, this is a power rule for functions because it's not x to the 6th, it is some function to the 6th. So let's just remind yourselves, you don't have to do this step, but I just want to remind you of what this looks like. If I'm taking the derivative with respect to x of u to the n, which is a function of x to the n, that our answer here is n u to the n minus 1 times the derivative of u with respect to x. So what we want to do is identify what that u is. Here the u is the 1 minus 5x. So I'm going to do this two separate ways so you can see it. The first way I'm going to do is sort of, I guess, the most efficient way to sort of do everything internally, and then I will show what this looks like if I want to break it into parts, depending on your level of comfort. So here I'm just going to use the pattern. And the pattern says to bring down the exponent, so 6. And then I'm going to have that original function, 1 minus 5x, to the 1 less power, 5. And then I'm going to say ddx of what u is, and here u is 1 minus 5x. Now, what I'm going to do here is I'm going to put brackets around this for reasons we're going to see in a second. right? And that's because I'm going to have to do a sum rule here, and I want to make it very clear that this whole thing is multiplied to both terms of the sum rule. Now that's not going to matter so much in this problem, but it would matter in some other problems. And so once again, sum rule d1 dx plus d dx. I put that on there. I could put that over here as well, just to show it's an operator acting on the thing rather than in the ratio. But there you go. So if we notice here, I have derivative of a constant, so that term is going to go to 0. I'll just do that in red. And so what I'm left with here is 6, 1 minus 5x to the 5th. And then in brackets, and I'm going to keep it in brackets just so that we know kind of like the eye can track with the changes, right? This is very clear to a reader, i.e. me, that you know how everything is organized, and using soft brackets and hard brackets sort of alternately really helps tell this story. Now, on that same problem, let's say that you are just sort of a little bit newer to this and you don't feel comfortable just using the patterns and you want to be more explicit about the fact that this uses the chain rule. You can do that. You can say let u equal 1 minus 5x. And then I'm going to come back over here and say u is equal to, or the y is equal to u to the 6th. And so now I'm going to do dy du is equal to 6u to the 5th. And I'm going to say du dx is, right, ddx of 1 plus ddx of negative 5x, which of course is 0 minus 5. And so now I have du dx as negative 5. I have dy du as 6u to the 5th. And therefore I can say that dy dx is equal to dy du dx, which is equal to now 6u to the 5th times negative 5, or 6, and then I have to do my replacement back into what my u is, and I get the same answer. It's just structurally a little different. As you can see, this takes fewer lines just to use the pattern, but it also takes a little bit more comfort to use that pattern and feel confident with your work. All right, cool. So let's move on to the last problem of this grouping, which is 2n, which is a very weird looking thing. It's the square root of x minus 1 over x plus 1. All right, so we're going to go slow here because we have a lot of similar looking expressions. So there's a whole bunch of ways of doing this. I'm going to do this in a way that I think is inefficient the first time, and then I'm going to show you a much more efficient way to do this. Because what we want to do is try and rewrite this in the best way in order to solve this problem. And some people might rewrite this the following way: x minus 1, x plus 1 to the 1/2, and then call it a day. I don't think that's the best rewriting, but it is a rewriting. So looking at this, I've got a power rule for functions involved in this. And so let's do this. If I were to then do d dx of this expression, dy dx following the pattern, I would have 1/2. I would take the x minus 1 over x plus 1 expression, and I would change that to negative 1/2. And then I would have to do the derivative with respect to x of x minus 1 over x plus 1. And this expression here is a little bit awkward, so let's just take a second and rewrite this because I have a quotient here. Now in your calculus classes, you'll probably learn something called the quotient rule. I despise the quotient rule. I think it's an extra thing to learn and has no particular utility. And now, to be perfectly honest, as someone who has a little bit of dyslexia, the patterns in it just have never stuck in my head, and so I always screw it up. But remember, every quotient can be written as a product. And products I feel really comfortable with because I've got a product rule. And so I'm going to put this now in brackets so I can distinguish what's going on. So I've got 1/2 this expression of x minus 1 over x plus 1 quantity to the negative 1/2, and now I've got the product rule. So remember what the product rule says? That says the first function, so that's x minus 1, times the derivative of the second, so d dx of x minus 1 to the negative 1, power rule for functions there, plus the second function, x minus 1 to the negative 1, times the derivative of the first function, and that's actually going to be I almost screwed up there, minus 1, boom. Now, next line. Oof, okay. 1/2 x minus 1, x plus 1 to the negative 1/2, and in that parentheses, I've got x minus 1, and now here, oh, hold on, I screwed something up, right? Look at that already. Plus 1, and then plus 1, and then minus 1. Ooh, sorry about that, folks. And so here we go. And actually, do you know what? Why was I able to see my error? I was able to see my error because the way I have this structured allows me to see how one thing changes into the next. So it's actually, this formatting is very convenient for being able to see your own errors. So now, looking at this, I've got a power rule for functions right there. So I'm going to use a different color just so that I know I can track what all my changes are. So that says bring down the power, so negative 1/2, raise it to the 1 fewer power, negative 2, or 1 less power, excuse me, and then derivative of what's inside, d dx of x plus 1. Close parentheses. Now, I'm going to run out of room here, so let me show you a little trick. Rather than try and squish it in, which is what most of you do, which is terrible, let's not do that. We're going to go plus, and then what I'm going to do is I'm going to go down to the next line, and I'm going to indent. Now, normally I would only indent about this far, but because I'm inside this bracket, I'm going to indent into the bracket. And so here I go. X plus 1, quantity negative 1, and then show my sum rule, d dx of x, I didn't need that parentheses, plus d dx of negative 1, but I might as well be consistent now here. And so that is then that, and now another hard bracket to end that. So looking at that, this is going to go to 0. And actually, while I'm at it, this is just going to go to 1. So where do I go on to the next line? I could probably collapse that back to 1 line. Notice, by the way, I'm keeping all of my equal signs lined up so it is pretty, right? Structure and organization on the page matters. Okay, so I've got x minus 1, and now going to go to my red pen, negative 1, x plus 1 to the negative 2, and now I've got to do my sum rule, hard bracket, just so I can do this, d dx of x plus d dx of 1, boom, right, because we are required to show all of our processes, right, and that closes that, and then plus, and all I have left here is that x plus 1 to the minus 1 term, because that whole thing went to 1, close brackets. I was able to do that without making my life difficult and without smushing. No smushing allowed. So now I think we are on our last step, because that is going to go to 1 and that is going to go to 0. Notice when I was doing the crossouts, I did it in the opposite color just for clarity's sake in my own head, right? So 1/2 x minus 1 over x plus 1 to the negative 1/2, x minus 1, parentheses, minus 1, x plus 1 to the negative 2, and then this just all becomes 1, so I'm just going to leave it out, plus x plus 1 to the negative 1, done. Look, there are no more derivatives. Once there are no more derivatives, you are done. Unless the problem says, do it in simplest form, once all the derivatives are done, so are you, okay? And the reason for that is if I'm not going to do something with this expression, like if this is part of a larger problem and then I need to use the derivative expression to solve something, I would most definitely want that in a simpler form. But this problem doesn't require it. Now, I'm just going to put this in a simpler form now so that we can see this. So I've got 1/2, because I'm going to show another solution. I want to show my two solutions are identical to one another. Okay. So what do I have here in the parentheses? I've got a negative x minus 1 over x plus 1 quantity squared plus 1 over x plus 1. There we go. And now what I'm going to want to do here is combine these. So I've got to do an x plus 1 on top and bottom. So I've got 1/2 x minus 1 over x plus 1 to the negative 1/2, and then I've got negative x minus 1 plus x plus 1 all over x plus 1 quantity squared. So now let's see what that does. Well, that's sort of a weird expression there, because the negative here, what that does is like it flips things around. So let's just distribute that so we can see it. I've got 1/2, and I've got x plus 1 to the 1/2, right? Flip the fraction, got rid of the negative exponent, and then I'm distributing that sign, negative 1 to the 1/2. And then in here, let's see what I've got on the top. If you notice here, negative x and positive x go away, right? Negative is 1, so on the top I've just got 2, okay? Over x plus 1 quantity squared. So now my 1/2 and my 2 go away. And if you notice here, the half, and then this becomes 3/2. And so what is my answer then? Actually, that goes away. My answer here is apparently 1 over x minus 1 to the 1/2 times x plus 1 to the 3/2. And there we go. Okay? Whew, a lot of work there. Like I said, that's the inefficient way of doing it. Let's rewrite this easier. So if I started with this, actually, it starts with the square root of quantity x minus 1 over x plus 1. I'm going to rewrite this to get rid of the exponents, or to get rid of the radical, as well as get rid of the denominator automatically. So I've got x minus 1 to the 1/2 and x plus 1 to the negative 1/2. So much simpler as a starting point. And so if I take the derivative with respect to x of this, dy dx, I've got the product rule first. So first positive times the derivative of second. This problem is so hard because all the numbers are the same, but the signs aren't. And so it's so easy to do a mistranscription here. X plus 1 to the negative 1/2. And then derivative of this, the first. So second times derivative of the first. Boom. And now what I've got here is a power rule for functions internally within each of the two terms. So I've got x minus 1 to the 1/2, a positive 1/2, right? And then this is going to be, I probably could just do this with black since I'm not interchanging. So negative 1/2, x plus 1 to the negative 3/2. Ooh, that's interesting there, because, right, that's what we had. This is x plus 1 to the negative 3/2. Okay, and then now we're going to have to do the derivative of the expression itself. Boom, close parentheses, hard brackets there. So x plus 1 to the negative 1/2. And then once again, bracket, bring down the power, 1/2. X minus 1 to the negative 1/2, right? And then d dx of x minus 1. Close brackets, and then we're good. All right. Oh, cool. That also was in our final expression. So there's a lot of neat things happening here. So here we go. I've got x minus 1 to the 1/2, open bracket, negative 1/2, x plus 1 to the negative 3/2. And now what I'm going to do here is my sum rule, d dx of x plus d dx of 1, boom, boom. That's going to 0, that's going to 1. I don't trust myself to fit all that in, so I'm going to indent here on the next line, x plus 1, negative 1/2. If you know your handwriting is terrible, folks, and it's really big, don't squish, use the indent. X minus 1 to the negative 1/2. And then do my sum rule, d dx of x plus d dx of negative 1. Okay, and I know it's frustrating that that these terms essentially go to 1, and you're like, why do I have to do the sum rule when I know it, right? I know a lot of things too, but that doesn't mean that we don't have the burden to show and prove what we know and why we know it in the right sequence, right? So here we go, x plus 1 to the negative 3/2. And then that becomes 1, so I just close the brackets there, plus x plus 1 to the negative 1/2, and then in this brackets I've got 1/2 x minus 1 to the negative 1/2, and there we go. So what can I do here? Well, let's start combining things. I'm going to just get rid of negative exponent just to show it comes out to the same thing, because technically I'm done because all the derivatives are gone, and that would be totally acceptable as an answer. But just to kind of show that this comes out to the same thing, I've got equals x minus 1 to the 1/2 times negative 1/2 times, or over, x plus 1 to the 3/2. And then I've got plus, I've got 1 over x plus 1 times 1/2 times 1 over x minus 1 to the negative 1/2. Okay, so if I want to combine things here, what am I going to do? Well, I need to multiply this fraction here by an extra x plus 1 to the 1/2. Okay, and that'll get me the right denominator here. And over here, I need to multiply top and bottom. Let me move this over by x plus 1 to the 1/2, x plus 1 to the 1/2. Right? Multiplying both by 1. Okay, so what does that give me? Oh, hold on a second. Whoa. I nearly messed it up. This should be an x minus 1 to the 1/2, because it's this term I'm trying to get over there. Darn it. I'm not, hold on. This is terrible. That should be a plus, because the whole reason is I moved that into the denominator in order to get rid of the minuses. Oh, it's so hard to mess this up. Let me rewrite this line in a nice way, folks, because I think that this line is way too messy. X minus 1 to the 1/2 over x minus 1 to the 1/2, and then that's my factor of 1, x minus 1 to the 1/2 times negative 1/2 all over x plus 1 to the 3/2 plus 1 over x plus 1. I want to just stick the 1/2 up here just to make it a little bit cleaner, and then 1 over x, hold on a second, yep, that's that, x minus 1 to the 1/2, and then this was us multiplying over that extra bit in order to get the same denominator. Okay, there we go. Whew. So what does that do here for us? Well, a couple things. So that becomes an x minus 1, so I've got negative 1/2 x minus 1, and then the common denominator is x minus 1 to the 1/2 times x plus 1 to the 3/2, which is a good thing, and then I've got plus 1/2 x plus 1 to the 1/2. Something is screwy. Something is screwy, folks, because it should come out the same, but we're not getting it the same. this powers the thing that is messing us up, it looks like. So something went haywire. Let me just go back in my own work and make sure that I did that right. I think something is missing an exponent somewhere. Okay. All right. All right. Let me just start this again. And that pen is out of ink, of course. I've got -1/2 times x minus 1 to the 1/2 over x plus 1 to the 3/2. That's that correct. Okay. Plus, looking here, I've got only 1/2 in the numerator. And then I've got an x plus 1 to the 1/2, and I've got an x minus 1 to the 1/2. All right, I see what my problem was. I should have been multiplying this first term, or the second term, by x plus 1 over x plus 1, not x plus 1 to the 1/2. Oof. And then this term gets multiplied as I did before with x minus 1 to the 1/2 over x minus 1 to the 1/2. Giving us, once again, here in the numerator, -1/2 x minus 1, done, that's it, plus 1/2 x plus 1 all over the denominator that we want, which is this. Perfect, because the negative x, half x, and the positive half x go to 0. The negative half and times -1 becomes 1/2, and then this becomes 1/2, so we end up with just the 1 over x minus 1 to the 1/2 x plus 1 to the 3/2, which is identical to the other solution. Woof, there it is. The point being, though, you didn't have to bring it down to common terms unless there was something in the problem that required it. But there you go, a solution to these problems.